Okay, so Arvin sent me an email last night that gave a list of things we might talk about, and one of those was ethics. So this talk was previously titled Uncertainty Visualization, and now it is titled Uncertainty Visualization as a Moral Imperative. So what happens when we ignore uncertainty? Here is a randomly selected uncertainty visualization from a paper. A mixed design ANOVA with sex of face as a within subjects factor and self-rated attractiveness and oral contraceptive use between subjects factors revealed a main effective face, F of 1, 1276 equals 1372, P of less than 0.00, no thanks. How about instead a coefficient table? We theoretically have uncertainty here. There's some standard errors. Maybe you could do a coefficient plot instead. Now we're doing confidence intervals. You might even say put a likelihood or a Bayesian posterior distribution on top of those confidence intervals. Still, you would ask the question, how easy is it to ignore the uncertainty? It's pretty easy. I could just look at that number, that dot, or that dot. This contributes to dichotomania, which has been implicated in things like the replication crisis. If I just spend all my time running experiments and all the ones that this doesn't overlap that, I publish it and I say I got an effect, and all the times that that overlaps that, I don't publish it, then we have publication bias. Okay, another example of dichotomania, probably a little more recent. These are probabilistic predictions of the chance that Trump will win the election from 3 different poll aggregators from the previous presidential election. A lot of people got mad at these poll aggregators because they said, this outcome was very surprising. Well, I mean, if that's a reasonably well-calibrated prediction, that's actually not too surprising that Trump would win. Maybe I represent this way and say, I gave you a ticket to a random seat in a theater, and I've colored the seats black in proportion to the chance that Trump would win. Probably on this side, you wouldn't be that surprised to find out that you ended up in a black seat and Trump won the election. So it turns out people are very good at ignoring uncertainty, but especially when we provide them with bad uncertainty representations. The flip side of that is there are actually some good uncertainty representations. The one that I just showed you is actually an example of icon arrays. These are used in medical risk communication. So here on the left and the right, we have 2 different possible treatments of angina, and then the success rate is visualized on a grid of, say, 50 or 100 people. And now you can imagine what's my chance of being one of the people who gets cured versus one of the people who doesn't. This is called a frequency framing or discrete outcome visualization of uncertainty. It turns out that this type of visualization improves people's reasoning under uncertainty. You could also ask, what is an icon array for a continuous distribution? This is sort of categorical. Here's another example, something I've worked on. Say you want to give someone a probabilistic prediction of when their bus is going to arrive at a bus stop based on a real-time tracking system. It's tracking all the buses in the city. This is the non-probabilistic prediction. You probably want to give them something more like this. What's the chance my bus shows up around here? What's the chance my bus shows up around 15 minutes? So obviously a long tail. It's kind of hard. This is a terrible estimation, perceptual task for people. You have to do ratio of areas in order to figure out how likely it is your bus is going to show up later. You also have to understand what probability is, which people don't really. Why not take a bunch of quantiles from this distribution and stack them up? This is a quantile dot plot. Now, if I want to find out what the chance is that the bus shows up 8 minutes from now or later, I just count 2 dots up from the left, and the answer is I'll miss 2 out of 20, or I'll get 18 out of 20 of my buses. Turns out this is also a perceptually efficient task. When I've used a low denominator, you can use something called subitizing. You don't even have to count. You just look. You know there are 2 dots there. The other thing I should say here is we've run sort of incentivized decision experiments on this type of thing, and it turns out not only can people extract the probabilities relevant to the decision more effectively, they can actually learn how to make the right decision over time. Hurricane error cones. Probably you've seen stuff like this in the news. This is a predicted path of a hurricane with an uncertainty band around it. This falls victim to what's called a deterministic construal error among a large proportion of viewers. They think that this is predicting the size of the hurricane. In fact, the opposite, when the hurricane makes landfall, it gets smaller. You can go like this, and now you don't make that deterministic construal error anymore. I'm giving you many possible paths of the hurricane. You could do this with fit line uncertainty. So rather than showing a regression line with a 95% confidence band where I will happily ignore the 95% confidence band, I might give you a bunch of possible regression lines. I might even do something like animate through a bunch of possible regression lines. So now you really, really can't ignore the uncertainty. And then I'll ask you, I'm going to stop this visualization at a random frame. How much do you want to bet that your research question is answered the way you want it to be? So the most notorious example of this in recent times is this New York Times election needle that a lot of people hated. Basically what this is doing, it's actually kind of complicated. Every 30 seconds in real time, while the election results are coming in, they're updating their model. This is generating a predictive distribution for the margin of error of the result. So over here, Trump wins. I think this was for Florida. Over here, Clinton wins. These are intervals on that predictive distribution. And then this needle is randomly fluctuating within the central 50% predictive interval. This made a lot of people mad. Very mad. There's a couple of reasons for that, I think. One of the reasons that this made people mad was that they misinterpreted it as a deterministic prediction because it was a live prediction. They thought that it was giving a live update on the predicted odds as opposed to the actual fluctuation being proportional to the uncertainty. And then I think the other reason it made them mad is because it forced them to confront the uncertainty. It made them anxious. In the situation where you just ignore this, you're quite happy to take wherever the needle is pointing and not be anxious about the outcome of an election that you really, really care about. I like this comment down here. The New York Times needle jitter is irresponsible design at best and unethical design at worst, and you should stop looking at it. I disagree. I think it should be redesigned a little bit. I think it should actually fluctuate more. I think it should not just be fluctuating in the central 50%. At the same time, I think it probably shouldn't be a needle because that makes people think that it's a deterministic prediction. But this raises the question, shouldn't anxiety be proportional to uncertainty? It's making you anxious, and it should make you anxious. Thus, uncertainty visualization as a moral imperative. Predictive systems should present well-calibrated uncertainty that cannot be ignored in ways that people can actually understand. Thank you.